3-degree receiving dish, collecting high-frequency sound waves and channeling them to the ears. The right ear is directed slightly upward, and the left slightly down. Because one ear is closer to the sound source, it detects sound sooner and louder than the other. This separation of sound allows the owl to calculate the distance to its source and enables the bird to see sound in stereo, to know what its prey looks like, where it is, even which way it's facing. The barn owl is totally dependent on sounds made by its prey. Yet, it has the softest of wing feathers and flies silently. Guided by the sound map in its brain, it hones in on its unsuspecting prey, mainly the house mouse. This silent hunter has mastered the cover of darkness. While the barn owl has the ability to see and hear in complete darkness, the kestrel can see where its prey has been. A hovering predator casts a shadow, and the undergrowth is literally a maze of escape routes. To overcome this problem, kestrels have a weapon that goes into the realm of a supersense. Being highly nomadic, they constantly move into new areas where they have no knowledge of what prey is available or where it is hiding. But their weapon enables them to detect signs of prey that are invisible by normal sight. They can see in the ultraviolet light spectrum. Ultraviolet light is highly damaging and over time causes blindness. Filters in the eyes of mammals block it out. Kestrels cope with the light's highly corrosive effect by constantly renewing damaged cells through their high metabolic rate. Rats and mice mark their runways with droppings and urine, which emits a type of UV fluorescence that kestrels can detect. The kestrel's eye view would appear like this. In this way, kestrels can scan large areas in a short time, looking for the greatest intensity of fluorescence as a sign of the recent passing of prey. It's a waiting game, but one that pays off for this miniature hunter with a super sensory view of the world.
Coming up, these toothed missiles are programmed to seek out and destroy. After the break.
Finding your prey in a vast environment requires a highly effective sensory weapon, and sharks have not one, but many. The ocean is a superb conductor of low-frequency sound, and sharks can pinpoint the movement of injured prey from more than a mile away. When in close range of its prey, another weapon comes into effect. Sharks have a series of sensory channels filled with fluids running down the sides of their body, known as the lateral line. Within each channel are tiny sensory hairs that pick up vibrations in the same way that the hairs of our eardrums pick up sounds. They also have an extraordinary sense of smell, able to detect 1 part tuna extract in 25 million parts of water. Once within about 60 feet of their food, their sight becomes effective. Sight that is equally effective in dim light as in bright. When feeding, a protective membrane slides across the eyes to avoid damage to this vital organ. Yet the shark can still see, not by sight, but by the detection of electrical fields. Sensitivity so great that it can pick up a variation of 100 millionth of a volt per yard. It's an arsenal of weapons, featuring both long and close-range sensory perception and contributing to the shark's reputation as the ultimate predator. Dolphins are among the most creative and versatile of all hunters, with a weapon available for every hunting scenario. When on their own, they employ their remarkable sonar weapon. Unlike man-made sonar that transmits in a single wavelength, the Dolphins operates on a broad band, including both low and ultra-high frequencies. If a dolphin locates fish, it pursues them at about 20 miles an hour, with continuous movements of its head from left to right, repeatedly checking its bearing until it has reached its target. The low tones can penetrate depths of over a mile, while ultrasonic tones are for the close-up work. But dolphins have a range of weapons, each adapted to their individual food source and location. In the tidal creeks of South Carolina, they kill with sound. The force of these blows sends out powerful sound waves that stun their prey. Here, dolphins use teamwork to trap their prey. At low tide, they silently patrol the mudflats, monitoring tiny fish by sight alone. Pushing a wall of water before them, they sweep hapless mullet onto the shore. Each grabs what they can before turning back. Requiring as much as 40 pounds of fish each, they may hurl themselves at the banks for over 4 hours. This is only one of the dolphins' hunting strategies, one they have developed to suit this particular estuary. Given that dolphins are among the most intelligent and creative of all animals, it's not surprising that they are capable of working together. But even creatures that are small-brained and small-bodied can work together to achieve gargantuan feats.
Coming up, teamwork promotes a deadly alliance when Wild Discovery returns.
Have perfected the art of teamwork. As individuals, they are weak and puny, but together, they form a deadly alliance. To coordinate such a labor-intensive operation, there has to be clear delineation of roles and effective communication. The green tree ant has both down to a fine art. They communicate by sign language and scent. There are ants that pin down and restrain, those that nip and bite, and others that seem to give the orders. What appears as chaos is in fact highly ordered social cooperation. Social cooperation is also found among the wild dogs of Australia, dingoes. Though relatively recent arrivals to this continent, they are the only social carnivores to be found on this vast island. They have large numbers of young and develop strong social bonds with each other. As pups, this kinship manifests itself as playfulness. As adults, their alliance with others will be their most important weapon in the struggle for survival. Small game is relatively easy to secure, and when plentiful, dingo packs disperse into small bands or hunt individually. Dingoes are at the pinnacle of their food chain, and while eagles and pythons will take pups, their greatest challenge in life is to secure food. Even at this early age, a pecking order is being established. It's the strongest and fittest who feed first. As the pups mature, young males disperse into new territories in search of a pack to join. They must quickly learn how to tackle live prey. A large goanna is a challenging task. Feeding on carrion, this reptile's teeth are laced with bacteria. A bite could quickly become a seriously infected wound. The young dogs try to corner the reptile and prevent its escape underwater. But their lack of numbers and experience results in a lost meal. The dingo pack assembles for the hunt when game is large and fast. It's a test of canine cooperation and endurance. Kangaroos can outsprint a dingo, but tire over long distances. The dingoes must work as a relay team, with one constantly at the heels of their quarry. At times, even driving it into ambush. Those not in the heart of the chase recuperate in the surrounding hillsides. With a pack pack of 8 or more animals, they have the combined endurance to sustain a chase that can last several hours. When the dingoes bring down an animal, it is killed swiftly and efficiently. Dominant dogs will end up with the biggest share of the kill. If most animals of large litters survive, resources can be stretched to the limit, leading to intense competition. Death in fights or by starvation is then inevitable. Some are forced to leave the territory, usually young males. In times of drought and food shortage, dingoes resort to scavenging. A lone, starving animal has no chance of gaining access to what little food there is. As with all animals, weapons are imperative for survival. In dingo society, alliance with a pack is vital. It makes the difference between life and death.